I think it's better this way. It's a wonderful day, a wonderful time, a wonderful evening to be here once again. So I'm just gonna share the link just to conclude between today and you know, fully. I'm seeing how possible it is for us to have a class tomorrow, so we can at least cover this course by Sunday. We should be done. So by Monday we should be starting with something different. So retrospectively, in our retrospective class, we spoke about you know programming languages. We spoke about translators and a lot of things actually. So tonight we're talking about study unit 2, the basic principles of computer programming. So for the soft copy, it's on page 112. I don't know what it is on the hard copy, but here it's on page 112 for the soft copy. And so in this unit, we'll be looking at, we'll be dissecting the topic principles of computer, basic principles actually, basic things when it comes to computer programming. So the table of content for tonight's class is problem solving with computer, principles of programming, and we have stages of programming. Okay, we have someone with us already, so just do well to let us know who you are. So we have the introduction. We have computer programming is both an art and a science. In this unit we are will expose, we'll dissect some acts and science of computer programming, including principles of programming and stages of programming. So we have our objective. Okay, just try my mouse. Okay, so now problem solving. Okay, problem solving with the computer. Now the computer is a general purpose machine. This is one of the things we established in our first set of classes. We said computer is actually a general purpose machine, with a remarkable ability to process information. It has many capacities and its specific functions at any particular time is determined by the users. Definitely your computer does what you want it to do. It's actually very versatile. It does a lot of things, but what it is at the moment has to do with what Bethel Sunday. I think this is the first time you are joining us. I'm not sure I've seen that name before. Bethel Sunday. Well, it's great to have you join us. What department and level are you? Please do well to let us know your department and your level. So we have that. So now this depends. No, yeah, we said it. What a computer is at the moment depends on what the user wants it to be. Now there are many types of computer programs. However, the programs designed to convert the general purpose computer into a tool for a specific task or application is called application programs. Now, application programs are what converts the computer, which is a all-purpose machine, to being a specific thing at a specific time, directed by the user. That is what the application programs are. Application programs, for example, to some persons, computer is just the machine for typing documents, saving, booking meetings, and organizing their files. That is what the computer is to some persons. So to that particular person, computer the application program is what makes computer a file organizing machine. To another person now who is a web designer, computer to that person could be just a machine that helps in designing web and developing web, and so the application program makes it possible because application programs are programs that makes computer perform specific functions as required by the user. Basically, this same computer that I'm using here could mean something different to some other persons. Just like what we said then previous slide about in the military, where we have machines whereby they are just we have computers that they are just built, they are established for just one purpose. That is the function that computer is particularly is built up for. We said something like machines that are used in detonating ballistics and the likes. So application programs and programs that make computer perform specific function at specific time as required by the users. So these are developed by users to solve their particular data processing problem. Now, computer programming is the act of writing a program which a computer can execute to produce desired results. That is what a program is all about. A program, as I have just said now, is a series of instructions. A program is a series of instructions written by who? By a programmer. And why is this program written? It's written in order to give computers specific instructions to be delivered. Now, so we have a program is a series of instructions assembled to enable computer to carry out specific procedures. Now, a computer program is a sequence of simple instruction. It also means a sequence of simple instruction into which a given problem is reduced and which is in a form of computer can understand either directly or after interpretation. So now the thing is, computer programs are actually series of it says a sequence of simple instruction that the computer can comprehend. Sequence of simple instruction. Sequence of specific instruction that the computer can comprehend and give results after comprehension. So that's what a program is all about. So we have programming methodology. So we have the principles of good programming. Principles of good programming. Now it is generally accepted that a good computer program should have the characteristics shown below. Now we are looking at the principles of a good programming. Now we have a program must be accurate. People say computers don't make mistakes. That is because the programs are accurate. Computers can't make mistakes because the program written for that particular instruction is accurate. So therefore, computers can't make mistakes. They can only malfunction. And malfunctioning is quite different from making mistakes. So we have that as that. So accuracy, the program must do with it is supposed to be. The program must do what it's supposed to do correctly and must meet criteria laid down in the specification. Basically, a good program has to be accurate. It has to be reliable. It has to be what it is. It has to be efficient. It has to be robustness. There has to be this robustness. It should cope with invalid data and should not stop without indication or cause of source error. Definitely, it has to be robust. It has to be robustful. We have robustness. We have usability. The program must be easy enough to use and be well documented. It has to be easy for users to use. It has maintainability. The program must be easy to amend, having good structuring and documentation. Now, readability, the code on the program must be well laid out and explained with comments. Now, it has to be. So we have about 5 of them. We have robustness, we have accuracy, we have reliability, we have usability, we have the maintainability, and we have the readability. So those are the things for a good program. So we have stages of programming. So we have the preparation of a computer program involves a set of procedures. There are procedures to the preparation of a computer program, and these steps can be classified into 8 major stages, which are: first, problem definition, devising the method of solution, developing the method of using suitable aid, which is pseudo code or flowchart, writing the instruction in a programmable language. Now, for you to have a successful program, it follows 8 good stages. First stage, you have to first identify. Programs are written in order to solve problems. This is one of the things we said in our previous class. We have programs, written just like as I have explained a moment ago, that programs are designed to carry out specific instructions. So definitely, if there are no programs, computer might not be able to perform instruction given by the user. So that's a problem. So for a programmer to definitely solve this problem of computer responding to instructions from users, so now it has to first go through 8 stages, and these stages are: one, the problem identification. Why is this program required? You have to now devise the method of creating. After you've identified that is a problem, then you now have to devise the method whereby you have to create the solution to this problem. Then after you have worked on the method, you've chosen the method at which you want to solve the problem, then you have to develop a suitable aid. How to. Now you now have to write, and this how to has to do with this pseudo code or flow chart, because this is like breaking down like a rough estimate of the rough analysis of what your how to should be. So we have transcribing the instruction into machine sensible form. So we have debugging the program. We have testing the program. We have documenting all the work involved in producing the program. So that those are the 8 stages of programming. So we have problem and definition. Just like I've explained, it is the first stage of the process, and it requires a good understanding of the problem. You have to first understand what a problem is before you can identify with it. That's that for that. So we have devising the method of solution. You have to then the second stage involves spelling out the detailed algorithm, use of computer to solve problems. We have developing the method of solution. So we have all this. Developing the method has to do with several methods of presenting or developing methods used in solving a problem. So we are writing the instructions in a programmable language after outlining the method of solving the problem on a proper understanding of the syntax of the programming language to be used necessarily in order to write series of instructions. So we have transcribing the instruction into machine sensible form. So we have we have all that stats program. A program seldomly executes successfully the first time. It normally contains a few bugs. Errors are also referred to as bugs. Now you have to debug. Now you have to eradicate this error. In the process of locating and correcting the errors, there are 3 classes of errors. Now we have the syntax error, we have the logic error, and we have the execution error. During this process of writing this program, there's something that you come across which are bugs, and they are called error. So whenever you come across the word bug in computer, it's referred to as errors. So now these errors, we have 3 types of errors. We have the syntax error, we are caused by mistake coding, illegal use of features of programming language. We have logic error caused by faulty logic, and we have an execution error. Now the program works as intended, but illegal input or other circumstances at runtime makes the program stop. So we have that as that. So we just move on. So we have the program testing. Now the purpose of testing is to determine whether a program consistently produces correct or expected results. That's what the testing is for. Okay. Okay, so we have other methods of testing a program for correction. We have manual walkthrough. This program, according to the manual, the program traces the programmer traces the process step manually to find error. This is when a programmer traces the programming step to find errors. So we have use of tracing routine. This is available for the language. This is similar to manual walkthrough. So we have storage dump. This is a print out of the content of the computer storage location by examining the content of various locations. So we have program documentation, we have storage dump, use of tracing routine, and we have manual walkthrough. Those are the method of testing a program. We have 3 of them. So we have that as that. So we have some very useful things here. We have advantages of program documentation. We have it provides all necessary information to anyone who comes in contact with the so the program, just like documenting things. Advantages are it helps supervisor in determining the program's purpose. We have it simplifies programs maintenance, and that is that for that. Okay, just very quickly, I think there's something we should just about program documentation. It says here documenting of a program should be developed at every stage of the program cycle. Meaning that at every stage of the program cycle, you should document. Just not just that it will help you to identify where problems are, but it helps you to monitor to monitor your success. Now, the following are documentation that should be done for each program. Now, at every point in time, your documentation for each program should be problem definition stage. This problem definition stage, your documentation should be a clear statement of the problem. A problem definition stage in your documentation, you have to have a clear statement of the problem, the objectives of the program, what the program is to accomplish, source of request of the program, now the person official authorizing the request. So we have the planning, the solution step, we have the flowchart, the pseudo code, our decision tables and program narrative, and we have that. So we have the advantages of program documentation. It provides information as to the use of the program. It provides useful information as to the use of the program. It also provides operating instruction to the computer operator. Those are the advantages of program documentation. So we have conclusion. The intelligence of computer derives a large extent from the quality of the program. Definitely, computers are not as smart as you might think. It's actually the program that makes them smart, because the program is their genesis. You understand? So it's actually humans that has programmed whatever it is the instruction is dwelling on as being intelligent. So it's a program that are very important. As you can see how important the programs are, they determine what the response of the computer will be. So we have the intelligence of the computer derives a large extent from quality of the programmers. Now in this unit, we have attempted to present in some details principles and stages involved in writing a good computer program. Now, we've talked about the principles of computer programming, stages of computer programming, and interrelationship between different stages of programming. So we move to the next topic for tonight, which is flow chart and algorithm. Please permit me to take some water. I feel kind of dehydrated now. So we have flow charts and algorithms. So in this unit, we are going to be introduced to the principle of flow charts and algorithms. Now, the importance of these concepts are presented in detail. Steps and activities involved are also presented. So we have the objectives. In this unit, we grasp the principle of good programming ethics through flowcharts and algorithms. So we have, what is a flowchart? Now, the flowchart is a graphical representation of the major steps of work in process. The keyword in the flowchart here is the graphical representation. Has to do with images. It has to do with, it has to do with images. It has to do with lines, representing the major steps of work in process in process. Now it displays in separate boxes the essential steps of the program and show by means of arrows the directions in information flow. It shows in separate boxes. Okay, write a program on how to from Lagos. Okay, from a place called many of us who knows Ikorodu. That's where I was born and bred. So write a program about how a taxi can navigate through from Ikorodu, that's Ikorodu garage, that's a Benson, to Locust Housing Estate. That was our house. That was our rented apartment before we finally moved to our house there. That was at Adamo at Jebu Day Road. So for example, now you want to write a code on how to navigate for a driver to navigate through from Ikorodu Benson Garage to Locust Housing Estate, which is um, just after Sabo Market. So how do you get now? For you to do a flowchart of that, the 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 main destination is low cost housing estate, and where the current location of the driver is at Benton at the garage. So Benton garage, now you can have a box. We are trying to explain what the flow chart is like. You have a box. So now from that Benton garage, your arrow, you will draw an arrow pointing to the nearest bus stop after Benton. You're writing a program. You understand? So if the driver begins to move now, is the driver moving north, east, west, or south? So your arrow should be acknowledging where exactly the driver is heading. So if the driver is heading west, your arrow is pointing west. And if the driver should head west, moving from its current location, where is the next closest spot? I mean, that's how Google Map is being made, definitely. This is one of the process. Leaving that place, where is the closest location? Leaving garage, you are heading towards Ogijo Road. Yeah, you are heading towards Ogijo Road, the roundabout. So from Benson, from the garage, you're heading towards Ogijo Road, which is the roundabout. Then you put a box there. So your arrow, which is pointing west, is pointing at Ogijo Road. So Ogijo Road, it's two road. One takes you to Ijebu-Ode Road, and one takes you to Ogijo. So there are two arrows. One is pointing east, one is pointing south. So if you follow east, you are going to Ogijo, and that's not your destination. But if you follow south, you are going to Locust Housing Estate, that is your destination. So now your box stops at the roundabout, heading west for Ogijo, but the line continues at east, heading towards your destination. So there's another box, and that's how you keep getting the boxes. You keep pointing the arrows, telling us step by step on how the driver left his current location and is heading towards its destination. So basically, that's what the flow chart is. Shows you step by step process, step by step progress of the working process. So we have it uses boxes and arrows. We have that as that directions of information flow. So we have that as that. So we have flow chart symbols. Okay, now let's just quickly take this. The boxes most often referred to as illustrative symbols may represent documents, machines, or actions taken during the process. Now the area of concentration is on where or who does what, rather than on how it's done. Flowchart can also be said to be a graphical representation of an algorithm. That is, it is visual picture which gives the step of an algorithm and also the flow of control between various steps, just like what I've just explained. Step by step process of the progress of the step by step progress of the working process. So we have the flowchart symbol. Now the flowcharts are drawn with help of symbols, definitely. Now the following are the most commonly used flowchart symbols and their functions. So these are the symbols of flowcharts and their function. Now we have a symbol looking more like a capsule here. So this used to show the start or stop point. May show exits to a closed subroutine. So we have under page 120, we have symbols and functions. So there's this symbol here looking like a capsule, and its function is shows the start or stop point. It may also show exit or closed subordinate. So we have the one looking like this is more of I think it's a rectangle, if I'm not mistaken, used for arithmetic calculation of process, e.g. sum equals x plus y plus z. So we have square tilted to the right. We have used for input and output instructions. So we have something looking like a diamond, but have four sharp edges. So we have labeled with different decision results, yes or no, true or false. So we have a lot of symbols here. We have the symbol looking like a circle, used for entry or exit from another part of flowchart. A small circle identify a junction point of the program. Okay, we have arrows pointing to the east, north, south, west. We have pointing to each other's end in form of a box, used to show the direction of travel. So we have guidelines to drawing flowcharts. Each symbol denotes a type of operating input, output, processing, decision, transfer, or branch or terminal. So we have the guidelines now each symbol should denote types of operating units, operating input, output, and decisions. Now a note is written inside each symbol to indicate the specific function to be performed. So our guidelines now, flowcharts are read from top to bottom. Let's not forget it's a process. So it's continuous and a flow. There has to be a flow. A sequence of operation is performed until terminal symbol designates the end of the run. Very, very affirmative. Okay, flow charting. The problem, excuse me. Flow charting the problem. Now, the digital computer does not only do anything and cannot make unplanned decisions. Now, every step of the problem has to be taken care of by the program. The digital computer does not do anything that is outside its program. Everything it does is already in the program. So now every step of the problem has been taken care of in the program. Now, a problem which can be solved by a digital computer need not to be described by an extract mathematical equation, but it does need a certain set of rules that the computer can follow. A certain set of rules. I've got another definition for program. A program can be defined. This will be very interesting. If it's a pen on paper exam, because pen on paper exam you'll be asked to write, use your discretion, use definition and the likes. But it's quite unfortunate. It's just garbage in, garbage out. The computer is based. Computer based test. Pardon me, let me take some water. I feel so dehydrated. So now here's another definition for what a program is. It says certain set of rules that the computer can follow. Now if a problem needs intuition or guessing, or if so badly defined that it's hard to put well, the computer cannot solve it. Just as simple as that. The computer cannot work outside its program. Now you have to define the problem and set it up for a computer in such a way that every possible alternative is taken care of. Just like was it today when I was making a research on something, and I went to Google and I searched it on Google, and Google could not find it. Google said error. So that means this program has not been written on Google. I was surprised. I was looking for actually a statement. I searched it, so I couldn't get not even a clue from Google. That's the biggest search engine in the world. It's crazy. If a problem is we've done that now. The box is linked by means of arrows, which shows the sequence of the operation. Definitely, the boxes and the arrows shows the link, the sequence of the operation. Now, the flowcharts act as an aid to the programmer who follows the flowchart designed to write his program. So we have algorithms. Now, before a computer can be put to any meaningful use, the user must be able to come out with with or define a unit sequence of operation or activity. Now, just to the program, but here is recorded as operations or activities logically ordered. Now, which gives an unambiguous method of solving a problem or finding out that no solution exists. Such a set of operations is known as the algorithm. Now, the algorithm now, I beg your pardon, the algorithm now can simply be defined as a well-defined sequence of operation or activities. And what does it do? It gives an unambiguous, it gives an easy method of solving problems. Okay, let me put it this way. Algorithm is like a system that exists. The existence of the system, which is referred to as algorithm now, is as a result of a sequence of instructions given in a simplified way. That's why it says here that it's a sequence of operational activities logically ordered. Logically. Meaning that if somebody is doing 2 plus 2, 4, this same person can do 5 plus 5, it's 10. So all these things they are set of activities, sequence of activities, logically ordered. So when you are asking this, it's giving you this. When you're asking 2 plus 2, it's not giving you 5, it's giving you 4. When you're asking 5 plus 5, it's not giving you 50, it's giving you 10. Because what? It has been logically arranged. It's a sequence that has been logically arranged unambiguously for the computer to comprehend. That's what the algorithm is all about. Now, an algorithm named after the 19th century scholar Abu Jafar Muhammad Ibn Musa al-Khwarizmi is defined as the following, roughly speaking. An algorithm is a set of rules carrying out calculating either by hand or machine. An algorithm is a finite step-by-step procedure to achieve a required result, just like what I've said earlier on. An algorithm is the sequence of computational steps that transforms the input into an output. An algorithm is a sequence of computational steps. We have an algorithm is a sequence of operations performed on data that have been recognized in data structure. So we have what's going on with my material. Okay, yeah, so we have that as that. Now, the most famous algorithm in history dates well before time. Okay, Mr. Jolas, oh, you are just joining us. You came a bit late, that's unusual, but it's great to have you join us still. So we have Mr. Jolas, we've gone far. Okay, we are on page 121. We've gone far. We are done with the first unit. This is the third unit now. We are done with the second unit. This is the third unit now. We are on flow charts. And we have created flow charts. We are now on algorithm. So we have the most famous algorithm, in the history dates well before the time of the ancient Greeks. This is Euclid's algorithm. Now let's take note of this. Euclid that's let me check. That should be module 3. Yeah, should be module 3, where you find study unit 3, flow charts and log algorithm. So we have that as that. So now the most famous algorithm in history dates well before the time of ancient Greeks. Can you imagine? This is the Euclid's algorithm for calculating the greatest common divisor of two integers. Now, before we go in some otherwise complex algorithm, let us consider Now, okay, let us consider one of the simplest but common algorithm that we encounter every day. Now, the classical multiplication algorithm, for example, to multiply 981 by 1234. Now, this can be done using two methods, two kind of algorithm. Now we have multiplication by American way and multiplying the multiplicand. I'm not sure of that. I think that's a typographical error. You know, and after another by which digit of the multiplier taken from the right to left. So we have according to what we have here. So by the American way, we have 981 multiplied by 1, 2, 3, and 4. So as you can see here, we have 3, we have 3, 9, we have 2, 4, and we have 2, 9. I think it's a multiplication done in an American way, and it goes slants to the left, and keeps going and going. So we have the multiplication by the British way. This is the multiplication one after the other by each digit of the multiplier taken from the left to the right. Okay, here it's taken from the right to the left. When it comes to the American way, it's taken from the right to the left, but the British way is taken from the left to the right. So we have the algorithm therefore can be characterized by the following: a finite set of sequence of actions, characteristics. Now they're talking about the characteristics. Finite set of sequence of actions as a unique initial action. We have each action in the sequence as required successor, and the sequence terminates with either a solution or a statement that the problem is unresolved. So we have that as that. So we have example: write an algorithm to read values for three variables. We have the u, v, w, and find value for results from, just like the illustration I made about you moving from Benson, which is a garage in Ikorodu, and you are going to Locust Housing Estate. Just like the explanation I gave, your current your the program you are writing now, the flow chart for the program will have to do with your current location and your destination. So in between your current location and destination, the U-turns, the movement step by step, the nearest junction, the closest bus stop, all this will be acknowledged with arrows and boxes. So you can remember, just like we said in the flow chart, there are some symbols that whenever you see them, you know, okay, this is for the start and for the stop. So as you can see, the very first step, the very first symbol we are seeing here, which is the one that looks like a capsule, speaking about starts, and the process continues, and it goes on and on, and it definitely has, just like I said, there's a current location, and there's an expected end, the start and the stop. So we have that as that. So that explains that. So we have all this explaining just the explanation I gave earlier on. So the starts, and there's okay, okay, all these flowcharts are still explaining the use of arrows, symbols, and everything. They all have a meaning, and we have also talked about them. So we have the set sendo code. So we have the sendo code. The sendo code. Now it's a program designed aid at aid that okay, it's a sendo code is a program design aid that serves the function of a flowchart. It serves the function of a flowchart in expressing the detailed logic of a program. Now, sendo code is a program, and let's not forget we said programs are instructions written out for a computer. Instructions written out for a computer to carry out, and this instruction must be comprehensible by the computer before it can carry them out correctly. So instructions must be unambiguous for the computer to comprehend. So now, and when writing this instruction by the programmer, every logical thing you can think about concerning that problem must have been included in that instruction for the computer to function well. So now, a program as we have established. And the sender code is also a program on its own, and it aids the function of the flowchart in expressing detailed logic and program. Just like as I said earlier on, there's a program I did, the ALX program. Sendo code is like a code you write on how you intend to solve a problem. So sendo code and flowchart. Basically, flowchart uses more of symbols and more of symbols and arrows. Sendo code does use that too, but it's more detailed compared to flowcharts. So sometimes the program flowchart might be inadequate for expressing the control flow and logic of the program. Can we see that now? They are not talking about inadequacy of flowchart. Now, using the sendo code, program algorithm can be expressed as English language statements. Now, these statements can be used both as guide when coding the program in specific language and as documentation for review by others. Now, because there is no rigid rule to constructing Pseudo's code, the logic of the program can be expressed in a manner without confronting to any particular program language. A series of structured words is used to express major program functions. These structured words are the basics of writing program using the technical letter structure program. Now we have examples of these programs. We have construct pseudo code for problem in example above. Begin, store to sum, store 1 to count. So as you can see here is it's more of writing a solution to a code, writing a solution to a problem, or writing out instruction in words. Flowchart does more of symbol and arrows, but pseudo code here does more of puts more of a written form. So we have it does more of it in a written form. We have the decision table. So what is a decision table? Now, a decision tables are used to analyze a problem. Now, the conditions applying in the problem are set out and the actions to be taken as a result of any combination of the condition arising as shown. Now, let me take this again. Decision tables are used to analyze a problem. Decision tables, they are used to analyze a problem. Now, the conditions applying in the problem are set out. They are dissected. They are spewed out. Now, the decisions, the conditions, and the actions to be taken, they are dissected. Now, the combination of these two being dissected gives rise to what is to be done next. Now, they are prepared in conjunction with or in place of flowchart. This is we talked about the flowchart. Now we've spoken about the pseudo code. Now this is about decision table. All these things work hand in hand. We said decision table use more. We said flowchart use more of signs, symbols, and arrows. Pseudo code now use more of it speaks more of the inefficiency of the flowchart. Has to do with writings in words. Decision table now has to do with analyzing, a problem. And we said something about dissecting the conditions and the actions to be taken. So now they are prepared in conjunction with or in place of a flowchart. Decision tables are a simple yet powerful and unambiguous way to showing the action to be taken when a given set of conditions occurs. A given set of action to be taken when a particular error occurs. There's something we call frequently asked questions. I've been able to work or been privileged to work on some international platforms, and when you are setting up your gig, you'll be asked to project, think, okay, this gig I'm offering, what are the frequently asked questions? This person is not there. This person, you can only put your gig You can only make your gig live and people can view it and they want to come. Okay, they've gone through it. So you have to act as if you're a customer. Okay, this gig I want to purchase. Okay, now what are the questions that I might want to ask the seller? So now decision table now is now telling us that what are decisions to be taken when a particular condition appears. So as a programmer, when a particular error, you have to think about this program I'm writing. What if something like this, a condition like this will occur? What should be done? That's what decision table is all about. And I said they are simple yet and powerful, unambiguous way to showing the action to be taken when a given set of conditions occur. Moreover, they can be used to verify that all conditions have been properly catered for. You have to properly cater for as a programmer. Bugs will definitely come. It is necessary. Bugs, it's all about you catering for them. I don't know if you remember, we said bugs are error. Let's not forget that. There will be definitely you have to debug. Keep provision for debugging. So we have that as that. Now, in this way, they can reduce the possibilities that are rare or unforeseen combinations of conditions that will result in confusion about actions to be taken. So decision table have standardized. Okay, I think I need to use my mouse. Okay, decision tables have standardized formats and comprise of 4 sections. These are the 4 sections in decision table. We have conditions. Stop. This section contains a list of all possible conditions which could apply in a particular problem. Condition stop. List of all possible conditions that could apply in a particular problem. We have condition entry. Section contains different combinations of the condition. Each combination being given is a number, term, row. So we have action sub, we have action stop. This section contains a list of the possible actions which could apply for any given combination of conditions. So we have that as that. So we have action entry. This section shows the actions to be taken for combination. Okay, action, we have writing the instructions in the programming language. That's program coding. We have the instructions contained in the algorithm must be communicated to the computer in a language it will understand, before it can execute them. Now, the first step in writing instructions of programming language, which is coding, is the process of translating the planned solution to the problem. This picks the flow chart, pseudo code, decision table is the statement of the problem. Now, now this is something you should note. For you to successfully write a program, which is a program coding, you must have observed a flowchart, pseudocode, decision table into the statement of the problem. Now the program flowchart, pseudocode, decision table, as the case may be, is a guide by the programmer as it describes the logic in the medium of programming language. Now the coding is usually done on coding sheets or coding forms. It's not something that is done on Microsoft Word or Excel. There's a sheet for it because it has to do with the instruction the computer is carried out. So we have that as that. So we have conclusion, the flow chart, decision table, pseudo codes, and algorithms are essential ingredients to writing a good program. Just like as I said earlier on, if they are done properly, they lead to reduction in bugs in programs. They help minimize time spent in debugging. In addition, they make logic errors easier to trace and discover. Summary: in this unit, we've been able to learn flowcharts and we're able to identify flowcharts as a graphical representation of the major steps in work in progress. Now, it displays the separate boxes the essential steps of the program and shows by means of arrows the directions of information flow. Now, Decision tables are used to analyze a problem. We've said something about decision table. The conditions applying in the problem are set out and the actions to be taken. If as a result of any combination of the condition arising as shown. So we have the pseudocode is a program design A to serve as a function of the flowchart expressing detailed logic program. So we have the algorithm, a set of rules carrying out calculation either by hand or by machine. So thank you very much, guys. This brings us to the end of today's class. Um, I really want to say a big thank you for you guys for sticking around. I believe you have been able to get a thing or two in tonight's class. So thank you very much, and I look forward to seeing you in subsequent classes. Bye bye.